Okay, so you've got your little flip book here, right? We're going to start getting the Wayback Machine and talk about graphing the quadratics, okay? Because again, that's part of where you're going to kind of probably start with some basic stuff like this in college algebra. If you review it a little bit now, it'll all be great then. So first we want to find the axis of symmetry. Do we remember basically what that means? Like, you know what it looks like to have a parabola, right? Oof. So if I have a parabola that looks like this, right, exactly, right down the middle, just like it sounds, the axis of symmetry would be that right there. And so one thing the axis of symmetry helps me find is my maximum or minimum. But when you want to find that, it is a vertical line, which means it's an x equals line, and it is just x equals negative b over 2a. That's all it is. And maybe I need to remind you that quadratic functions look like this. Y equals ax squared plus bx plus c. So we know what a and b are. If I just take a quadratic function, so you should know by looking at number one, it's a quadratic, it's going to look like a parabola, it's going to open up. But if you just randomly pick x's and y's, then there's no telling what part of that you're going to get. You might only get like this part of it over here, and that doesn't tell you anything, right? So to do that, we find the vertex using the axis of symmetry, complete the table of values, and we're going to placing the vertex in the middle row, and then graph the points and connect to create a parabola. So for number one here, if I want to find the axis of symmetry, x equals negative b, negative 2, over 2a, which is 2 times 1. That's really just negative 1, right? Do we agree with that? So then I'm going to, that means here, I think I have 1, 2, 3, 4, 5, 6, 7. Okay, so my x value of negative 1 is going to go in the middle. That's how I know where to start that. And then we can just go by ones going in either direction. When it goes up, 0, 1, 2. This would be negative 2, negative 3, negative 4. Now, do we know how to find these values? I would take negative 1. Not that you have a lot of room, probably, but we'll do it right above here. And we're going to substitute it in. So y equals negative 1 squared plus 2 times negative 1 minus 5. Don't worry, we're not going to do this for every single one. I'm going to just give you those answers. But negative 1 squared is 1, and then minus 2 minus 5. So what's that going to give me? Negative 6. Good. Negative 6. And then to find the rest, you would just do that for all the other points, right? So I'm just going to give you those other points. So here's what your y column looks like. I'm pretty confident that you can substitute numbers in. Plus, this lesson would take forever if we substituted everything in as we went along. And 3. Okay, there are our ordered pairs. Then once you have those written down, go ahead and go in there and plot those points. And then when you're graphing these by hand, it's not an art class. Make an honest effort. Try not to make it look like a V, and just do your best, because you know it's supposed to be curved, so we're just going to do our best to make it look like it's curved and goes to those points. And there's our quadratic. Now, you can use graphing to solve a quadratic, and my solutions would be right here. But I would not trust my graph, especially if it's not on a whole number, but it at least gives you a ballpark area about what your answers would be, if that is something that you're trying to do. Not the best method of solving, but it is a method of solving. Okay, are we all good on graphing that? Yes? All right, so then let's look at this one down here. Find your axis of symmetry. I got 2. Did y'all get 2? Did it give you enough time to get 2? 2 here. Then fill in your X column. And what do you know about, how is this, besides obviously it's a different function and we're going to have different values in our, but what's a big difference between this one and number 1? How's it going to open? Down. And we know it opens down because A is negative, right? That's something I would assume that we know. So if this is 2, we'll make this 3, 4, and 5. Should make this 1, 0, and negative 1. Because it will always be symmetric, so that just helps you with that. And then I'll just give you the Y values, because again, you can substitute that in. That's not something we need to focus on here. 5, 8, 5, negative 4, negative 19. And then look at your Y column here and your Y column on the last one. Do you see how you started and ended with the same number? And this one was in the middle, right? And that's basically the center. We expect that to happen because we found the axis of symmetry, and that's just telling us this. So really, when we go to graph it, if we just graph these points right here, then it's easy. We don't necessarily have to count for the rest of them. So when and I don't even know if negative 19 is probably not even on here, is it? It's not. I think the best you can do is, we can even skip that one. So if we go to 0, negative 4, make a point, then 1, 5, and 2, 8. Then since it's symmetric, I know that when I'm 1 away from there, I have to do that point, and then I can move 1 more over to get to my 4, and then I can just match it up with negative 4. It's a whole lot less counting on those little tiny grids. And we're just going to pretend like mine looks decent because it's so hard for me to match that up there. Now we're going to talk about transformations because they come up a lot. But can anybody tell me? Oh, are y'all still plotting points? I'm sorry. I didn't mean to get ahead of you that quick. Am I going too fast? Let's slow down. What transformation is happening in number 3? There's only one. It's down. Okay, it goes down 7. So you know what your parent function looks like, right? At 0, 0. All that's happening is get it shift down 7. That's all that's happening. So we actually already know what our axis of symmetry is. But if we were going to actually go find this, then we would have x equals, what is b? A is 1. What's b? 0, because it's not there. So I have negative 0, which makes no sense, but negative 0 over 2 times 1, that's just 0. Okay? So 0 goes in this insert, which is, again, what we expect because we started at 0, 0, and then we just shifted down. So this is 0, 1, 2, 3, negative 1, negative 2, negative 3. So our y values are going to be 2, negative 3, negative 6, negative 7, negative 6, negative 3, and 2. Then you can graph those. I probably, when we started this, if I hadn't found this foldable that I liked, I probably would have skipped the graphing part for now, but it was in the foldable, so I thought we'd at least touch on it because we'll come back to some other graphing stuff. Okay, we all good so far? All right. Once you're done with your graphing, go ahead and flip to the next part. So I know that I don't want to go too fast if you're still graphing, but okay. So now we're going to solve by factoring. Now, let's just make a little note here about the fact that this says solve by factoring. Sometimes you're just asked to factor. In order for you to solve it, it has to be an equation, all right? And step one, you move everything to one side and set the equation equal to 0. So what this should look like is ax squared plus bx plus c equals 0. Okay? All right. Then it says move everything to set equal to 0 and then factor. Woohoo. All right, so before we do that, when we decide how we're going to factor, we look at C, okay? And if C is negative, then I know in the end, in the two binomials I get, that means, so if I have a negative C, that means the signs are opposite. And I will clarify what signs I'm talking about when we get there. Let's just get this written down. If C is positive, then you have the same signs. And whether it's positive or negative depends on whether B is positive or negative. And I always think that's a good way to kind of start, right? So let's look at number 4 here, because we did 1, 2, and 3. That's why this is starting with number 4. A is 1. If A is 1, that makes your life a lot easier, and we can go ahead and set up 2 binomials here. And that still equals 0. Then I look at C. C, which is 63, is positive. Positive C, I'm going to have the same signs inside of here. Then whether they're positive or negative has to do with B. Since B is positive, it is plus plus. So now I have x plus something and x plus something. All right? Now, you could have been taught to factor using a box and all kinds of other things. The boxes, I truly don't really understand, and this just seems like a huge waste of time. You are looking for 2 numbers that multiply to give you 63 and add to give you 16. Okay? That's what we're looking for. So what are the first factors of 63 that pop in your head? And you have to know your multiplication facts to make this stuff work. What do you think those 2 numbers are? 9 and 7, exactly. And again, if you don't know your multiplication facts, that's one thing that makes factoring really hard. Now, 9 and 7 are the first ones that pop into my head too. Is 9 plus 7 16? Yep, so that sounds like my answers here. So 9 and 7. And then you can check yourself. Make sure that a positive 9 times a positive 7 gives you a positive 63. And it does. Once you've got there, so we did step 1. We didn't need to move anything. Then we factored. Then we set each factor equal to 0. So now I do x plus 9 equals 0 and x plus 7 equals 0. Now, whether or not you actually do that specific step and like write that step down, that's totally up to you. Because I think that, we get to a point where we can kind of skip actually writing that stuff down, and that's okay. Then we solve it. We get x equals negative 9 and x equals negative 7. Then we write our answers as a set. Okay, I have a set of numbers. They really should be in order from least to greatest. That's not really a rule, but that's how you would see it. Might be how a professor might require it. Just kind of depends. But -9, -7. Not ordered pairs, but it's a set of numbers with a little squiggly brackets. We all good on that? Okay. I think and I hope at this level, when A is 1, we get pretty good at that with that in there. So let's look at number 5. Now, I first need to set it equal to 0. That should be my first step 99% of the time when you're trying to factor things. We'll talk about what that 1% is a little bit when we get there. But I'm going to move this 18 over because you always want your x squared term to be positive. So 2x squared minus 16x minus 18 equals 0. Now, A is not 1, but the first thing you should always look for is a GCF. Does this have a GCF? Yes. Could I factor this without factoring out the GCF? Yes, but that would make my life a whole lot harder. So I'm going to factor that out, and that's going to leave me with x squared minus 8x minus 9 equals 0. Now, I don't want to drop my 2 off, okay, because I don't want him to disappear right now, because if I need this fully factored, that 2 makes a difference. The 2 is not going to affect my answers, though, because I've taken it out. Now, A is 1 now, and what I'm actually factoring, so I know I'll start with an x and an x. I look at C. C is negative, which means the signs are opposite. Not only that, but since B is negative, the bigger number that goes in here is going to have to be the negative number, okay? Now, I need 2 numbers that multiply to give me 9 and subtract to give me negative 8. Negative 9 and 1. Good. Negative 9 and 1. And if it's something this simple, again, you don't necessarily have to write out x plus 1 equals 0, x minus 9 equals 0. You know whether or not you need to do that. If we do skip that step, then that means my answers are actually negative 1 and 9. So you just want to make sure you don't do those backwards. Okay. What questions do you have? Are we good? Yes, we can factor like that? Yes? All right, awesome. So now I'm going to look at number 6. It's quadratic, like I identify it. There's a squared in it. It's the largest exponent, so it's a quadratic. I want to try to factor it. So I need to set it equal to 0. Would you move everything to the left or to the right? Yeah, I would choose the right this time because that x squared is negative. And if I move everything to the right, then it's going to make it positive, which is more like what I actually want. So that means I'm going to have 0 equals x squared. And then because I'm going to add x squared to both sides, I subtract 8x from both sides. So negative 2x minus 8x is negative 10x. And then plus 25. Now, this is actually a special case. If you don't recognize it as a special case, it's fine. You just factor like everything else. So A is 1. And if you haven't talked about special cases in a while, you probably don't recognize it, which is okay, all right? X and X. 25 is positive, therefore the signs are the same. 10 is negative, that tells me it's minus minus. So I need 2 numbers that multiply to give me a positive 25 and combine to give me a negative 10. What are they? Negative 5 and negative 5, right? So we have 2 of them, which means I really just have one solution, and it's what's called a double root. This basically means that your function is, you have a 0 at positive 5 over here. And let's see, we'd be opening up this way. So it's going to come down and bounce off. And that's when it's sitting on an axis, this is what is happening here. You can rewrite this, not that you have to factor it. I just want to remind you as we're going through all this stuff, some different things. I could rewrite this as x minus 5 squared. Either way, okay, so sometimes that's, it cleans it up a little bit. Either way, I'm only going to have, I don't write this twice. I don't write that twice. I'm going to get x equals 5. And sometimes you only have one thing in your set. It's still technically a set. It's a set of numbers with one thing in it. What questions do we have? Are we good? All right, and we're only factoring quadratics right now. We're not getting into cubics or anything like that just yet. Well, let's look at this next one. Want to set this equal to 0, right? So I think I'd move everything over to the left. So when I do that, this will give me 7x squared plus 6x. And then what's negative 1 plus 1? 0. So I don't have to put anything, so that just equals 0. Okay? Still a quadratic. Still want to factor it. Am I going to end up with 2 binomials like I did before? No. First thing I'm going to do is look for a GCF. What's my GCF? X. So x, I factor that out. That leaves me with 7x plus 6 equals 0. In this case, I think it's a good idea to write down your little equations because this right here, this guy matters. We don't forget about him. If I haven't told you this once before, very first day of Algebra 2 will forever be seared in my memory because our teacher walked in dressed as the number 0 and told us how important he was and whatnot. So, but this guy, this is one of the factors. You set that equal to 0. And then you solve it, but it's already solved, so you got nothing else to do. Then you do this guy, 7x plus 6 equals 0. Even though that this is fairly simple, still a good idea to write it down because here's where we make weird mistakes sometimes. Because when I subtract 6, this will give me 7x equals negative 6. So x equals negative 6 over 7. So you don't accidentally get 7 over 6 because you're doing it fast and in your head. That's where the careless stuff happens. So my answer then in the end is, this is negative, so negative 6 over 7, 0. What questions do we have? Anything? Okay. All right, so then we have 9x squared equals 49. Now, could you solve this one by taking the square root of both sides right now? Yes, but this is in the factoring section, so we're not going to. It's also much safer when we factor, and I'll show you why. I have a quadratic. I'm going to set it equal to 0. So 9x squared minus 49 equals 0. Now, because I chose to do this way, it doesn't have all the different little things that can happen and what they're called and whatnot. But this is another special case that, I mean, I guess you could do it without knowing the special case, but it's way easier if we do. Can anybody tell me what this is called? Difference of squares. Good job. It's a difference of squares. So, a little bit of a reminder. Do we have any room anywhere? Maybe right above here you have a little tiny bit of room. I've seen where you had extra room to write. Difference of squared. If I have a squared minus b squared, okay, which is basically what I have, right? That is always going to be equal to a plus b, oh, that's a 3. I don't know where my brain goes sometimes, times a minus b. Is that easy? Or the minus can come first, it doesn't matter. So if I have a difference of squares, 9x squared is a perfect square, 49 is a perfect square. If they weren't perfect squares, it wouldn't work out like this. I can do this here. And then what's the square root of 9x squared? 3x. Okay, so I get a 3x at the beginning of both of them. And then one's a plus, one's a minus. And then the square root of 49 is 7. So this is what I get here. So that means I get 3x plus 7 equals 0, and 3x minus 7 equals 0. Then x is equal to negative 7/3, and x is equal to a positive 7/3, which you could list out like that, but you can also put plus or minus 7/3. Okay. Here's what happens when we don't factor and we try to just take the square root, we forget that you have to put the plus or minus and you end up with just one of them, and then that's a bad thing. That's why factoring is just a little bit safer. Okay. Everybody okay with all that? Yes? All right. So, number 9. What's my first step? Good. Minus 56. So 2x squared plus 6x minus 56 equals 0. What's my next step? GCF. Do you have one? Yes, because this is 2 and everything is even. So 2, and then x squared plus 3x minus what? 28. Good job. Equals 0. All right, then see if you can factor this one on your own. So I look at C and see that it is negative, so I'd have 2 different signs. Now if you started with the minus, that's totally fine. But I need 2 numbers that are going to multiply to give me negative 28 and combine, or basically subtract, since the signs are different, to give me 3. What are my 2 numbers? 7 and 4. Good. And that since this is positive, the bigger one's positive, and this would be a negative 4 there. Which means x is equal to negative 7 and 4. And I can't stress to you enough that what makes factoring crazy hard is when you don't know your multiplication facts, because you can sit there all day and never come up with numbers if you don't know what they are. Everybody okay with all that? What questions we got? Okay. All right, so let's look at number 10. It's set equal to 0. Great. Do I have a GCF? No. Okay, so and A is not 1. So that stinks, because the other ones I was able to get A to be 1. Now there's only one example of this. We're going to end up, before all is said and done with this, we're going to do some more examples on the back when A is not 1, because I feel like 1 is definitely not enough. But we're going to start here. So there's different ways to do this as well. I feel like the majority of people now are teaching this by grouping. There are other little tricks and tips and different things, but I really think that grouping, well, that's how I'm going to reteach it anyway. So I multiply A times C, and that gives me negative 30. Okay. So now that's my multiply 2 number. I need 2 numbers that are going to multiply to give me negative 30 and combine to give me negative 13. 15 and 2. Tell me why I can't use 3 and 10. Any ideas? Because it's a negative. Because if it's going to multiply to give me negative 30, the signs have to be opposite, right? And if I have a 3 and a 10 and the signs are opposite, they're not going to combine to give me negative 13. They're going to combine to give me 7, right? Either positive or negative. So it is 15 and 2. And then I'm not setting up my little parentheses like I did. I need to split this middle term right here. So this is going to be 5x squared. And I just decided that it's negative 15, right? So negative 15x, and then plus 2x, and then minus 6. So you want to double check yourself right here. that first of all, negative 15 times a positive 2 will give you a negative 30. And then also that if you combine these two back together, you get this. And if you don't check that, sometimes that's where things go haywire. Then this is factoring by grouping, so then we group. Right? I'm going to group these first two together, factor out whatever I can. I can factor out a 5x. That leaves me with x minus 3. Out of these two, I can factor out a 2. So positive 2, and that leaves me with an x minus 3. And that equals 0. When you get to this point, a couple of things. If your two little parentheses don't match, you either did something wrong or you can't factor by grouping for this one, which happens sometimes. The next thing is you're not done. You are not finished factoring. I don't know why, but I see a ton of people stop here and then start giving answers. I mean, yes, you can give an answer at this point, maybe, but if you do it correctly. But you're not finished factoring, and I think you are, so we're going to continue. I get this 5x plus 2. This is one of them. And then x minus 3 is my other one. Now it's completely factored, and now I can give answers to that, okay? And I do think some of you, maybe not all of you, might need a few more examples and work through a couple of more of those. We will. I really thought that I had written those on the back of this right here, which is where I worked it all out. Apparently I did not. So we're not going to do them today because they're not there. But my answer is going to be a negative 2/5 and a positive 3. And again, if you want to or need to write out the little equations so you don't mess them up, knock yourself out. You know where you are in your learning journey, I believe. Everybody good so far? Now, I definitely think we need some more practice on this. I'm going to give you the assignment, not today, but it's going to be in Delta Math. So if you need more practice with this stuff, remember this in Delta Math. The assignment's not there yet because I started putting stuff in, but then I was trying to be more picky about what I was choosing from, and they have different levels and stuff, and it was taking me a long time to make something decent, and I just didn't finish. But remember, if I give you like 3 to work on, and you're like, okay, I got those 3, but I think I need more, you can always do more. Okay, you can do more than the bare minimum, and again, that's on you to know whether or not you need to. Are we okay on this type of factoring, do we feel like at this moment? All right, difference of squares. How many of you feel like it's been a long time since you've seen that, and maybe we need to practice some more on that? Anything? Anybody? Or maybe just what you're doing in Delta Math might be enough to refresh your memory on that? Okay. And then, but I will work through some more of these with you, because that's where people start to make up math. All right, we good so far? All right, let's move along to solve by square roots. Okay. All right, so this method only works for equations, and then, all right, before I changed the font, I was trying to change some things and it wouldn't let me. Then I changed the font because this looks like OI, or I don't know what that looks like. It took me a while to figure out what in the heck are they trying to say. That's an exclamation point that in a very strange font just looks like an L or a 1 or an I don't know what. So what it's saying is you can only do it basically if you're missing your BX term. That's what it's getting at here. So we can just write in here, no B times X. That's what it means. So you isolate the x squared, which means you move the other, if it's set equal to 0, you move the other thing over there. Take the square root of both sides. But here, when you do this, don't forget your plus or minus. That's where things go downhill every time. And then we write our answer as a solution set, just like we had before. So when we look at number 11, yes, it's a difference of squares, and we could factor it that way. But we can also say that x squared is equal to 121. And then regardless of whether or not it's a perfect square, I can still finish it off. When I take the square root of both sides, I get x equals plus or minus, and what's the square root of 121? 11. Good. And then that is your answer. Okay. Easy enough on that? Okie doke. And then here, I've got an x squared. I have no bx term, so just like it said, we are going to isolate the x squared term. So this is going to move over here, and we'll get x squared equals what? 18? Oh, I'm looking at, oh, I just realized what I did. I put 16 for whatever reason. You have to also be able to add and subtract. Like, that doesn't seem right. Well, it's because that's wrong. All right, so then I take the square root of both sides. And I get x squared is equal to, well, 18 is not a perfect square. Plus or minus the square root of 18. But I need to be able to simplify this, right? And you could have been shown how to simplify this in different ways. I think we did like one of these on here when we were doing SAT stuff, if I remember correctly. We're going to make a little tree. What are two numbers that multiply to give me 18? 9 and 2. Okay, I heard 9 and 2 first. 3 and 6, that works too. But when you get to a prime number, you're going to circle it. 9 is 3 and 3. Okay? And then those are the end parts of my tree, right? So then what I really end up with, x squared equals, and then I've got plus or minus. I look for pairs. These two 3's come out of the little house as a regular 3. This guy doesn't have a pair. He stays inside. It's 3 square roots of 2. Okay? Everybody okay with that? What questions we got? Ask a question. What's your question? Because I'm an idiot. Thank you for asking. I just realized what you're asking. No, when I take the square root, it should not be squared anymore. Thank you very much. There you go. Any other questions? I don't know, because I did it wrong. I think I was so focused on that. I had 16 written down. I was trying to figure out what the heck I did. All right, number 13. Now, my x squared term is negative. I got two options. I can switch sides of everything, or is 243 divisible by 3? It is, right? And so if I divide it, then a negative divided by a negative is a positive. So you'll get x squared equals 81. I'm just going to tell you it's 81. As long as you can figure out it's divisible by 3, I think you can do that. Then we take the square root. Now the square root of x squared is x. And that equals, what's the square root of 81? 9. So it's plus or minus 9. Very good. And remember, it's plus or minus because we introduced the square root. If it was already there, it would be something totally different. All right. Now let's look at 14. I'm going to move this 27. So this will give me x squared equals negative 16. My x squared is positive, so I'm going to go ahead and take the square root of both sides. Now, as a little reminder, we have a lot of room there. We can just put it right here, I guess. You were probably told at some point in your math career that you cannot take the square root of a negative number. But then in Algebra 2, you learned that you can take the square root of a negative number. And what is the square root of negative 1 equal to? I. Okay? It's your imaginary number. So I know that, so basically I know there's going to be an I, and then I just worry about 16 here. So x is equal to plus or minus, what's the square root of 16? 4. And then since that was negative, I put the I on it. And that's all that's happening there. Okay. What questions you got? All right. Then let's look at 15. I need to get rid of that 2/3. I have two options. And which option I choose probably depends on whether or not I get to use a calculator. Because I can multiply both sides by 3 and then divide both sides by 2. That's totally legal. Would you agree with that? My other option is to multiply by the reciprocal. So if I multiply both sides by 3/2, okay, then these are going to cancel out, and I'm going to get x squared equals, well, I've got two options here. Now I could, well, 3 really. I mean, I could multiply straight across and then divide by 2, but I also could decide to divide by 2 first. Which one do you think would be a little bit easier? Divide by 2 first. Okay, we're going to pretend like we don't have a calculator and we're trying to make our lives a little bit easier. So I'm going to take 78 and divide it by 2. What is 78 divided by 2? What's 80 divided by 2? Yeah, 39. 80 divided by 2 is 40, so 78 divided by 2 is 39. So now this gives me 39 times 3. And to me, that's probably a little bit better than 78 times 3 and dividing by 2. You with me on that? That's just but again, with the calculator, you can do it however you want. So let's see. What's 3 times 30? What? 3 times 30? Is what, 17? Oh, yeah, but that's not what I'm asking you. 3 times 30 is 90, and 3 times 9 is 27. And then when you add those, yes, you get 117. And then minus, that's fine too. That works too. Whatever works for you. Or actually multiplying it out, whatever ends up happening in the end. So you get x squared equals 117. So when I take the square root of both sides, I'm going to get x equals plus or minus the square root of 117. Well, look what happens when we start to do this. This is one reason why sometimes doing without a calculator actually helps you a little bit, or even with it, if you're doing step by step and paying attention to what you're doing. Because when I take this square root of 117, and I need two numbers to multiply to give me 117, guess what they are? 3 and 39. And then what are two numbers to multiply to give me 39? 3 and 13. And those are both prime numbers, right? So then, x is just equal to plus or minus, and what is this going to look like once I clean it up? These two come out as 3 square root of 13. You got it. Okay. Y'all good on that? All right, we will commence here tomorrow. Probably go back and do a couple of factoring questions once I realize what I wrote them on the back of, because it's not what I thought I wrote them on the back of.